Step number 1, find the mass of carbon and hydrogen in the sample. Okay, so what we need to do is let's first figure out the mass of carbon. Well, in our combustion reaction, I'm just going to rewrite it so it's going to be a little bit easier to see. We said vitamin C plus oxygen produces carbon dioxide and water. And they also told us the amounts: 0.200 grams of vitamin C, 0.2998 grams of CO2, and 0.0819 grams of water. Okay, so the first part to this is we need to find the mass of carbon. What molecule in the reaction is telling us where carbon is coming from? Well, basically, carbon is coming from carbon dioxide. So we need to look at this number. But this number tells us only the mass of carbon dioxide. We need to figure out just the mass of carbon. So what we're going to do is we're going to do a lot of unit conversions. This is why I have really kind of pressured you to start doing these unit conversions. Okay, so even if I have no idea what I'm doing, what unit will go on bottom? Grams of carbon dioxide. Ultimately, we need to figure out how many grams of just carbon there are. We can't go directly into grams of carbon here because there is no relationship. Instead, what would I have to do? The only relationship involving grams of carbon dioxide is moles of carbon dioxide. And you find this according to the periodic table. So for every 1 mole of carbon dioxide, if you add up your carbons and oxygens, you would see that there are 44.01 grams of carbon dioxide. That allows us to cancel off carbon dioxide. And now we're left with moles of carbon dioxide. We have to do another unit conversion. What unit will go on bottom? Moles of carbon dioxide. Okay, now this might be a little bit challenging to see, but for carbon dioxide, we're going to go into moles of carbon. The reason why I can do that is because of the mole ratio. It's saying for every 1 mole of carbon dioxide for CO2, how many carbons are there in CO2? Only 1, so it's a 1-to-1 ratio. If I went into moles of O2, then it would be a 2 because there's 2 oxygens there. So now that allows me to cancel off moles of CO2, do another unit conversion, and this is going to be the last one, which will be nice. Even if I have no idea what I'm doing, the unit on bottom will be moles of carbon. And what will go up on top? Grams of carbon. All right, so for every 1 mole of carbon, how many grams of carbon are there? 12.011, because this is coming from the periodic table. This allows me to cancel off moles of carbon. Okay, now if you multiply through, so you take your top in parentheses, 0.2998 times 12 divided by 44, we should get a number of 0.0819 grams of carbon. Okay, so we found the mass of carbon. Now we need to find the mass of hydrogen. where is hydrogen coming from in the reaction? It's coming from water. So we have to use this instead. Now we have to do the whole unit conversions all over again, only for water. All right, what unit will go on bottom? Grams of water. Because grams are on top, grams has to go on water. And what will go up on top? Moles of water. I find this according to the periodic table. For every 1 mole of water, if I add up my hydrogens and oxygens, so 2 times 1 plus oxygen, which is roughly 16, it's going to give me 18.01. This allows me to cancel off my grams of water. And now I'm left with moles of water. But ultimately, I need to get this into grams of just hydrogen. So I'll do another unit conversion. What unit will go on bottom? Moles of H2O. What unit will go up on top? This is a mole ratio. And because we're looking for hydrogen, we're going to look for moles of hydrogen. What is this relationship? For every 1 mole of H2O, how many hydrogens are there? 2. So it's a 1 to 2 ratio. Okay, then I do my last unit conversion. Cancel off my moles of water, and now I'm left with moles of hydrogen. That will now go on the bottom. What will go up on top? Grams of hydrogen. And this is found on the periodic table. So if you look, you will see that the mass of hydrogen is 1.01 grams of hydrogen for every 1 mole of hydrogen. This allows me to cancel off my moles. And I am going to be left with 0.00919 grams of hydrogen. You may want to pause and just double check that you can get these two numbers. Step number 2, determine the mass percentage of carbon and hydrogen in the sample. Okay, so how would I do that? How would I figure out the mass percentage? Remember the mass percent. You're going to take your, whatever you're looking for. So let's say what you're looking for. In grams divided by your total times 100%. We had done this on the previous, like a few slides back, looking at the mass percentage. Okay, so let's say I'm going to look for carbon. We found the mass of carbon. We found that to be 0.08199 grams. But how much sample is there? Well, the entire sample is vitamin C. And our vitamin C they give us is 0.200 grams. And then we multiply by 100%. So we get 40.91% of carbon. Now we have to do the same thing for hydrogen. So we take what we found, the grams of hydrogen. Oop. And we take the divided by the sample, which again is 0.200. Multiply by 100%. So if we take the top number divided by the bottom, we should get 4.59% of hydrogen. Remember with the mass percent, if you add all of it up, it should equal 100%. Because remember, a percentage is 100. If I add up these two numbers, do they add up to 100%? No. Okay, so something is missing. If I go back to the previous problem, they said that vitamin C is composed of 3 things. What are the 3 things that vitamin C is composed of? Carbon, hydrogen, and oxygen. So we need to also find the mass percentage of oxygen. Okay, so how would I do that? Okay, remember everything has to add up to 100%. So carbon has to, or if we have 40.91% of carbon, 4.59% of hydrogen, and we're adding this together, how much oxygen would we need? Well, basically you're going to just be subtracting. So you're going to take 100% minus 40.91% of carbon minus hydrogen, and that will give us our percentage of oxygen. 54.5%. Okay, so now we have our mass percentage. Now what you need to do is you have to go through and we have to do the empirical formula, like what we had done on the previous slide. So combustion analysis is a lot more work.